Okay, I thought I'd make another video for section 12.1 that was giving you some examples that I saw that were in the homework. And so there's three separate things that I wanted to bring out here. And the first one is constructing a frequency distribution, and both a regular frequency and a relative frequency. I saw that asked a couple of times, at least in the homework, and it seemed like every time it was asked, it was a frequency distribution in which you just had one number. In the previous video, I showed you what they're calling a grouped frequency table that goes from a certain value to a certain value. Here, each of our x's are going to be just a single value. And so as we construct this relative frequency table, I apologize for this small little data graph up here, but I'm looking at this data that's up here in this little white box. I actually cut that out from one of the homework problems so that the examples that I'm doing are really tied to the homework. And so as we look at this box, we want to write down all the numbers that we see and then count their frequencies. And so I think these are people's favorite numbers between 1 and 9. And so the lowest number I see is 1. And what we're going to do is look in here and see how many ones we see. I see 1 across the top row. And is that it? I think that's the only one that I see. So its frequency is 1. And we'll have to wait for the relative frequency. Then let's go count the 2s. And the 2s, I can make this box bigger by doing that. How many 2s do we have? 1, 2. Actually, I think I can cross them out. 1, 2. And I already counted that one. So 1, 2, 3, 4, 5. Looks like I got 5 2s. Right, and so I'm going to come in here and write the number 5. So let's come back in here. Do we see any 3s? I do see a 3. Even if we don't see it, I think we have to list it and put its frequency as 0. So we start with the lowest one, which happens to be 1. And now we're looking for 3s. I see 1, just 1 3. Okay, only 1 3 in there. And so we have a 1 again. Then we're going to go see how many 4s there are. And it gives us a quick idea of the distribution of favorite numbers. And are there any 4s? None across the top row. Here's a 4. There's a second 4. I think that's it, just those 2 4s. Being able to cross out like this really does help. So it kind of stinks when it's on the computer screen, right? So 5. Got more 5s, I bet. Let's see if I can bring that up big again. 1, 2, 3. Oh, not a lot more, just 3 5s. 6. Let's go in there again. 1, 2, 3 6s. 7. 1, 2, 3, 4 7s. 8. Move this down a little bit. And 9. So let's go look at the 8s first. 8, 1. Just 1. Okay, just that single 8 in that top row, it looks like. And 9. In 9, we have 1, 2, 3, 4. So it looks like we have 4 9s. So they're pretty evenly distributed. There's no ramp up or anything. That is a frequency table. You're literally just doing busy work counting stuff. Relative frequency says, well, what's the percentage in each class? So let's go ahead and add up all of the numbers here that are in the F column. So we're going to add up all of these because what that is the total number of data points. So we have 1 in the first category, 1 1, 5 2s. So 1 plus 5 plus 1 plus 2 plus 3 plus 3 plus 4 plus 1 plus 4. And it looks like we have 24 pieces of data. Does that make sense with what we had here? We had 1, 2, 3, 4, 5. Yeah, a 6 by 4 would be 24. So we do have 24 pieces of data. And for the relative frequency, when we go to figure out the relative frequency for this one, we're going to take 1 and divide it by 24 because 1 out of 24 were in there. And when we do that, we get a 0.0416. And so I don't know how they're going to ask us to do the frequencies, if they're going to say round to the nearest percent or the nearest tenth of a percent. We'll go to the nearest tenth of a percent. Hopefully you're comfortable knowing that that's 4.2%. As we put a percent on, we move the decimal point in twice. I'll do that in a different color. So as I move this in twice, I get 4.16%. And so I'm going to change that to 4.2. If I look at 5 divided by 24, I'm going to get, as I look at 5 divided by 24, let me show you what I get. 5 divided by 24, I'm getting 0.20833, or 20.8%, right? And then 1 we already know is 4.2%. So we can go to all these ones, right, to save ourselves some time. And then 2 divided by 24 is 0.0833. So they'll say 8.3%. No other 2's. 3 divided by 24, 12.5%. Here I got, when I did 3 divided by 24, it came out to be 0.125. And if I move that decimal point twice, just to show that again, I get 12.5%, and that's what goes into that 3 area. A 12.5%, a 12.5%. The last ones are 4 divided by 24. Should go on forever, yeah. It's 0.1666 repeating, or 16.7%, and 16.7%. Now, what do you think all these percent should add up to? You don't have to do this, but it's a good way to check whether you did the right thing. If I take 4.2, 20.8, add to that another 4.2, add 8.3, add 12.5, another 12.5, 16.7, 4.2, and another 16.7, I get 100.1%. So it does add up to be 100% of the data. Of course, that's what it would have been. Where about 4% is as number 1. You can see very quickly, the percent breakdown in there. Relative frequency will help us understand the size of a number absent of knowing what the total amount was. So if I told you, hey, in terms of people's favorite numbers, number 2 was 20%, was said 20% of the time, you would know, well, that's really big, right? Because they had lots of options to go through and do that. But that's what you would do. You're going to fill in a table just like that. We needed to get the frequency counts first, and then the total frequencies, and then we were able to get the relative frequency. The other things that are in here are stem leaf plots, and these are purely organizational. There's nothing really to do off of these other than to organize. And so a way a stem leaf plot works is you break off stems. And so it's categorizing things into groups. So the typical stem leaf plot breaks off the front number. Now, if you look at this data, there's numbers that are as low as 6 and as high, it looks like, as 36. And so we are going to try to arrange this from low to high. So as we look at these, there's numbers that have no tens part. And those numbers are these ones right here. 8, 6, right? 9. Those 3 numbers have no tens part to them. And so we put a 0 out there when that happens. In fact, the directions in the book tell you to do so. Now we're going to arrange these in numerical order. 6, 8, 9. So it pretty much shows us that this is 3 high there. Let's go in again and take a look at what's in the tens area. So if we go to the tens area, well, here we have, and let me see if it will let me change the color. It will. Let's go blue here. 19, 18, 11, 16, 10, 11, 16, 14, 18, 18, 16, 16, oh, missed one, 14. And I think that's it. I think everything that's not circled right now is 20 or higher. And so let me go back, and we want to, again, arrange this in order. So there was a 10, so we'll take care of that 0 first. And there were some 11s, 2 11s. And you want to keep your numbers kind of directly underneath because it's going to give us a size. So let me go back to this. After the 10 and the 2 11s, what's the next number? Looks like it's 14, and there's 2 of them. So we'll go get those in there. So 4, 4. And then 16, it looks like. 16, 16, 16, 16. 4 16s. And the nice part about doing it this way is you keep track of the numbers that are in that tens block. I think there were 4 of them, right? 1, 2, 3, 4. Sorry, I didn't put 4. So let me make sure there's 4. Yeah. 1, 2, 3, 4. And then the number 18 happens 1, 2, 3 times. And then there's the number 19 that's out there. And so you're keeping track of the numbers, and you're also getting a histogram, basically, that's coming out of there. Then there's numbers in the 20s. What do those look like? Let's go circle those in even a different color. Let's go green. 20, oops, didn't switch my color. 23, 21, 28, 23, 22, 25, 20, 21, 21, 22, 23, 24. And so there was a 20 right here, so we have a 0 followed by 21 and 21. So a 0 and 2 1s. So we'll just come back out here and a 0 and 2 1s. And then what's next? 22. We got 1 22, 2 22s. Oh, let's just double check. I missed a 21. So we need another 1. And 1 22, another 22. That looks like it. So I need to put on my additional 1 because there is a third one. 22, 22. Couple 22s. There's a 23 that we see there, and a second 23. Oh, and a third 23. Here's 1, 2, 3. 3 23s. And then let's keep looking at this. Is there a 24? There is. And a 25. And a second 25? No, doesn't look that way. So let's go back in here again. 24, 25. And then what else is circled green? Just the 28. And so we'll put an 8 in there. And again, we get in a size there. And then the 3. It's everything that's not circled. So there's a 32 and a 36. And so this gives us a rough idea of the shape of the data. Right? They say that is approximately normal. I don't know if they're going to harp on that term in our book, but that's what we get with the stem leaf plot, is a picture that looks just like that. In the computer, I think you're just typing all those numbers in. You could have what's called a double stem leaf plot. And what's happening with the double stem leaf plot is you're splitting it in half. And so you usually use this when you have a lot of data. And so if it's not organized, it's a little bit of a pain to go through and do. And it's not organized right here at all. But essentially what would happen, I'll show it to you with the tens, with the double stem leaf plot. With something like this, we're all in the hundreds. And you can see we range from 110 up into, do we get to the 130s? I don't think I see a 130. So, but we do have a 10. And we're going to split the tens in half. 11, 11, right? There's 100 and something. And then 12 and 12. And we're only going to put in that first one numbers 0 through 4, and the second one 5 through 9. 0 through 4, 5 through 9. 0 through 4, 5 to 9. That's what we're going to put in there. So let's go look at this. Let's go look at the 100 numbers. Here's 102, 109, 101, 106. Let's just stop there. Let me just give you the idea of what this does. You would say, oh, we have 101, 102, but when you get to 106, it goes down here, 109. That's what's happening there. Now, we would obviously continue. There's more numbers in the 100 range in there, but that's just the general idea. And what you get is a more spread out version of this. It's only really possible, actually it's possible in both of these, right? We'd have had nothing in that first column, 6, 8, 9. If we were to split this one, it would look like this. 0, 0, 1, 1, 2, 2. Let me move this down. Oops. Thought I wanted to get that up there. Oh, brother. Okay, let me move that down. 2, 2, 3, 3. And it would have looked like this. 6, 8, 9 would have been in that first category. 0, 1, 1, 4, 4. 6, 6, 6, 6, 8, 8, 8, 9. 0, 1, 1, 1, 2, 2, 3, 3, 4, and then 5, 8 down here. And then the 3, it would have been a 2 and a 6. That's what they call a double stem leaf plot. So it might not be an effective use of our time to continue in this video showing this. I mean, if I did continue, I would be looking for other numbers that started with that were in the 100 block, right? So I'm circling a few here that we would add on to the mix. And so you would look at the entire data set. I don't want to give you impression that it's the first row, and that's why I'm continuing to talk. But there was nothing in the second row, in the third row, the 109, in the fourth row, the 107. And then you would go back and say, okay, what do I need to add on to this? And they do like them to be in numerical order. And so as we look at this, we have to throw in these 107s, 101. So there's an additional 1 that needs to be put in there. Right, there's another 101. Oops. 101. And then we had the 102. So we took care of that 101 that's down there. But then we would have to pick up the additional 106. And it's just an organizing type of thing. 106. Remember, I had a 9. I'm just going to park it out there. 106 needed to be picked up from right over there. We have some 107s that we never had. Some 108s that we never had. A couple of them. And another 109. And that's what that would look like. And you would do the same thing for those in the 110 block. And then the 120 block. And so it's just an organizational thing in order to get us to be able to quickly have an idea of the distribution of the data. This looks even more normal right here. If I come back, looks pretty nice going through. Normal is a bell-shaped curve, and so that's what it's starting to appear like. So just interesting stuff, though, to play around with. A lot of